Hello, so today we're going to learn about bitmap images. Now the first task that you can do, and this is optional, is you're going to create a bitmap image yourself. Okay, so if you open up the bitmap image starter, which is this sheet here, you're going to find on a second page some coordinates. So for example, if you go to y15x5, so I would go, here's the x-axis, here's the y. So we go down to 15, go along to number 5, click on number 5, go to the paint bucket up here and select, well, any color you want. You don't have to select back. Then I would go back here and I would simply put a strike through on this, or highlight it. We'll just go to strike through and cross it out. So completing starter, pause this video now. Welcome back. Okay, so I hope you enjoyed creating that starter. So I'm just going to share the PowerPoint again. Here we are. Now, what we're going to look at today is a representation of images. So for those of you that have studied computer science before at GCSE level, or if you studied ICT, obviously you've got a familiarity with how images are represented and what bitmap images are. So we're going to show an understanding of how data for a bitmap image is encoded. We're going to use the terminology associated with vector graphics by drawing objects, property and drawing list, and then justify where bitmap graphics and or vector graphics are appropriate for a given task. Okay, so now firstly let's look at what bitmap images are. So here you can see there's an image right here and it's zoomed into this board to see what it is. Now you look at this image and you may think that it's distorted or grainy or made up of lots of squares. Okay, well, what bitmap images are is bitmap images are made up of individual little squares called pixels. Okay, each square has its own color and it's represented in its own way. So now what they are is the idea of bitmap images is used to build up the image from a number of small boxes of a single color. So each box, each little pixel has its own color. So the trick of the image is that if you're far away enough from it, you can imagine your eye and brain is basically fooled into seeing one of millions of tiny little coloured squares. Okay, so basically walking far away enough from it, you can see a whole image. Now each square, as I said before, is a pixel, and that is short for picture element. Okay, so each one of these squares is an element of the picture. So now you are familiar obviously with digital cameras, but mostly digital cameras now are used on our phones. And you know from looking at your phones, you can tell how many pixels the camera is. And obviously, the more pixels that it is, then the clearer the picture. So basically what it is, you've got these tiny, tiny little squares that have to take up space. And obviously, the less space there is, the bigger the square has to be. So that's when you see these images that look blurry and, you know, and the resolution's quite bad. But the more pixels there are, simply, the clearer the image. Okay, so you can see this camera here is 20.1 million pixels. Okay, so that means each image will contain over 20 million of those tiny little squares. Okay, so and obviously, like I said, the more squares there are, the smaller they will be, the clearer the image. Now resolution. So this camera has 5 megapixels. That means there will be 5 million pixels per image. Okay, so if you look too closely or magnify the image too much, as I said, then you will see the illusion is simply, well, it's spoilt for you, because what it is you're going to see all these squares and it takes away the magic, and that is known as pixelation. So when you can see the pixels quite clearly, it's known as pixelation. Now, each pixel can be addressed by one colour at a time. So, but each colour has each pixel has its address. So this means under the computer control, the colours can change. And a rapid update is why the video is possible on the screen, okay? So a new bitmap image replaces the previous one at least 25 times looking for a smooth video. So this is what happens. So basically a video isn't, necessarily you moving. What a video is lots and lots and lots of pictures that move obviously quite fast, so it gives you the illusion of moving. So now here's an original image and here's a new image, okay? So you can see here, each of these pixels have been coloured. So now colour. Basically, bitmap images can have up to 256 levels of colour on an 8-bit scheme, okay? So other schemes such as black and white obviously are possible, okay, but each pixel is 3 bytes, which is why the file sizes tend to be so big. So for example, if you was to create like an image, using Paint, and you save it, it's a massive file size. Then when you convert it to something else like a JPEG, it's much, much smaller, okay? So now basically what happens is this is the levels of how it works out is that it's 256 multiplied by 256 multiplied by another 256, and that will equal to 16 million. So that means 16 million colours are possible within each pixel. Okay, so like here's an example here and another one here. So you can see the amount of colours that are in them. Right, so now these are the points that you would consider for an A-level computer science exam. So the bitmaps are simply made up of individual pixels. Each pixel is an addressable unit, which allows subtle changes to be made into each image. Okay, because it means that you can actually change one pixel at a time. Obviously it'll take a hell of a long time, but it can be done. So bitmaps can be compressed to reduce the file size, but this may result in a loss of detail. So what happens is when you actually change a file, okay, so the thing is, the bitmap files are, as we know, because you can tell by how many colors they have and how many pixels they have, are incredibly detailed, okay, and they have lots of data, they have lots of colors, so that's why the file size is so big. Now, if you was to compress the file, then what would happen is that file would become less detailed. All the lots and lots of detail will be removed. So that means loads of colours will be removed and so on. Now, some of these details that have been moved, that maybe you might not be able to see with your own eye. So now each pixel can represent a colour, and every pixel can be different in a colour. So this can result in a very, very, detailed image. So the bitmap takes lots of storage space, as the information tends to be stored for every pixel. So large bitmaps images take a long time to open and load. So the more pixels there are, the better, and the resolution and the quality of the image are better. Okay, so here's the difference between a vector image and a bitmap image. So as you know, the bitmap image is made up of pixels, okay, like the units of light, the squares you can see here. But a vector image is different, okay, because a vector image is actually made up of points and curves. So these images are actually made of coordinates, okay? So you can see here that you can see all the points and curves that are put here, whereas you can see with a bitmap, it goes by each individual pixel. Okay, so what I'd like you to do is complete task 1, okay? So if we go here, I'm just going to share this screen with you. In fact, I'm going to, hold on, make this bigger. Here we go. So what I'd like you to do is do some research and describe a bitmap image. Then I'd like you to know, say what you know about the pixels. What is the difference between a vector image and a bitmap image? Discuss the colors used in bitmap and discuss the image resolution. Then investigate and discuss file sizes for compression for bitmap. And then remember and take a look in detail a little bit more about the points you need to know for the exam. Okay, very best of luck to you.